Okay, officially good afternoon. Thank you all for being with us as we kick off not just a Zoom presentation and Q&A, but really another chapter of discussion about the journey to carbon neutrality for Oberlin College. My name is Nina Axelson. I work with Evergreen Energy, and we have had the privilege of working with Oberlin College for a number of years, going back to some of the early carbon neutrality planning efforts. And I'm really excited to be part of this conversation today, and I'll be your moderator, joined by some really stellar folks as part of the Oberlin College community, as well as my colleague, Michael Ahern. So we have a little bit of a program to get through here, and so I want to cover a few logistics. So we have a Q&A and a chat function in this Zoom platform. What I would ask is that if you have a question related to the carbon neutrality and sustainable infrastructure program discussion, that you use the Q&A function. It's actually a little bit easier for us to track and answer questions when they're put into that section. If there are any issues with being able to hear or see an attendee or any other kind of technical difficulties with the Zoom platform, or something you would like to have one of us connect with after the session, feel free to put that in the chat, and we will be monitoring both. I don't want to make it confusing for folks, but just want to make sure we don't lose track of questions. We'll have about a half-hour program here with Megan, Michael, Wenling, and Stephen, and really excited to have you hear from them about various aspects of this programming for Oberlin College. And then we are trying to protect about half an hour for your questions, recognizing there may be more questions than we have time for today. So I just really want to make sure people know that we will try to follow up with any questions that are posed and not answered. On the program website, carbonneutraloc.com, there is actually an FAQ, and we will be adding questions asked in these sessions to the FAQ to make sure that we are continuing to keep a robust set of information for folks interested in all the aspects of this programming. And just want to encourage as much connection point to us and the other people involved with this program as possible. So with that said, I'm really happy to be able to hand this over to Megan and Michael for the next section of presentation. Megan is the Assistant Vice President of Campus Energy and Sustainability, and a really stellar leader in this work that I've been really privileged to work with over the years. And she's going to tell us a little bit more about the program goals and objectives and purpose as we start to get into a few more of the details. So I'll hand it over to Megan.
Hey, thanks, Nina, and thanks to everyone for jumping on this call to learn a lot more about the Sustainable Infrastructure Program. So I wanted to start by sort of giving you the framework about the major call for action here. It's the heartbeat of this entire program is carbon neutrality by 2025. And that is how all this work got started. And Oberlin has an incredible history as well as culture with sustainability in mind, and we have for years and years and years and years. And so we are continuing that work and that legacy to work on our carbon neutrality efforts. And this is sort of some of our very recent efforts that has incredible intention and meaning behind getting to carbon neutrality by 2025. So the biggest contributor to our carbon profile is our heating system on campus. So that has been the focus of a lot of this work. And in that discovery of within the last 6 or 7 years or so, we realized just how important it was to address a lot of other needs on campus and do it in a way that we're actually able to implement this program. And so the current state of our infrastructure, especially our steam system, is past the end of its useful life. In many sections, it's over 100 years old. I'll show you a pretty ugly picture. It's a little scary about how we're heating South Campus later on in this. But this program is designed to address a lot of those infrastructure needs, not just in the heating system, but as long as we're doing work there, simultaneously, it makes sense to address our cooling system needs. And that includes an expansion of our cooling system. So right now there's about 15 of our campus buildings that are connected onto our district cooling system. But yet we have the need to increase summer programming, and we've got the need to increase cooling on campus. So if we were if we were just kind of hanging out in a lecture hall or on this, I'd ask how many people live in a residence hall that's cooled, and it's probably very, very, very few of you. And so there's an incredible need to expand the cooling system. So that became part of the scope of this. And then there's a whole bunch of support network pieces in terms of our utility infrastructure that it made sense to address too. And that includes updating, modernizing our electrical infrastructure on campus, our fire protection throughout our buildings, and also the IT fiber network that runs throughout campus. So as long as we're going to be dug up in some places on campus, it makes sense to address all of those needs within this work, and it's efficient to do so. So, and then finally is that, that implementable and finance plan. This piece has really set our current work apart from any other carbon neutrality work, any other sustainable infrastructure work that has happened in the past on our campus. So these are pretty big projects, and we actually need them. We need them to get implemented. And so that business structure, that finance structure, by how it all happens, has been a major piece of this work, and is really, really a way that we're able to make meaningful action here. So let me get into a little bit of our carbon profile, and this speaks to why carbon neutrality is really reliant on our heating system and how this all got started. 7 years ago or so, when we were doing our resource master plan work to figure out how we get to carbon neutrality completely, we looked at our carbon profile, and you can see here, the campus was still using coal to heat a lot of our buildings on campus. Natural gas and electricity are the hugest piece of our carbon profile. And so that became the focus. That scope 1 and 2 of our greenhouse gas inventory was the real focus here. So this seems scary, but the great thing about our campus infrastructure is that we are really poised and set up through our district energy system to impact a big, big piece of that all in one foul swoop. So Nina, if you could get into the next slide, I'll talk to you about district energy and what that means and how it serves Oberlin College. But basically, we have one big boiler that's located in our central plant that's right behind MUD. And so we've got one big boiler that heats about 56 of our buildings currently on campus. And there's also some chillers in there, and that is how we cool a lot of our buildings. So from that big boiler through underground pipes that run to each of our buildings, that is how we're able to heat and cool many of our spaces. It is an incredibly efficient and sustainable method to heat and cool buildings within a tight footprint of which a college campus is, that applies to a college campus. It applies to a lot of downtowns. A lot of developments utilize district energy as their main heating and cooling source. It's, economies of scale, essentially. And so that is really, how we heat and cool our buildings on campus. And so it's pretty important asset, and it also allows us to really pay attention to that system solution to address our carbon neutrality issues. But here is the major problem on our campus, is that our existing system is aged and it's ugly and it's scary. So if you can move into the next slide, I'll show you a picture of a pipe that we pulled out of the ground about a couple months ago, and this was from South Campus. So you can see this is how we are currently heating our campus. And so, we cannot go without heat on our campus. And so we are needing to address these issues, and time scale of this project is really important. So I'll get into some of the program goals that we've set for this effort, and time scale is a big one. So I've talked about our permanent and significant carbon reduction, permanent significant cost savings. I've also talked a little bit about the financial sustainability of this effort, but a couple areas that I want to focus on is the resilient and reliable system solution. So part of building an infrastructure like this, you have an opportunity to do this really once in a lifetime, not just once in a career, but once in a lifetime. So you have to really do it right, and you've got to build it in a way that will allow campus to be resilient in the face of whatever comes our way in the future, not just from heating campus or cooling campus perspective, but also in case if we become we grow or we expand in any ways. So just building this system to allow it to be a little bit flexible is important. And this is a key component of some of the solutions that we've come up with in terms of our different tracks of this program work. So some other really fun pieces of this program are the community benefit perspectives. So a big piece of this program and district energy in general is that you have the capability in a system like this to not only serve your college campus, but also offer a carbon neutral source to benefit the community. So our Oberlin College community also has a carbon commitment by 2050, I believe theirs is, to be carbon positive. And so their climate action plan has identified some of our work within our heating infrastructure and cooling infrastructure and infrastructure upgrades in general as a way to help the city with their carbon profile. And so if we're able in this program work to add that tool to the city toolbox, then we will gladly do that in this program work. And so we're designing the program to allow community buildings to also connect to the system in future phases if that is something that the community wants to do. And so that's a really, really fun piece of the program work. And there's lots of education around that within the community. But I think the highlight for some of the educational benefits of this program work is our work with our students and the educational components of this program work. So we've been incredibly intentional about this program and engaging our campus community from a curriculum perspective and educational perspective on energy systems and what the difference is between, for example, thermal and electricity and some other components. So Stephen and Wenling will get into that a little bit in their portion of the conversation. But for those of us that work on the project, this is paramount to our programming and a major, major emphasis and goal. So you can see that this program is incredibly comprehensive and it is intended to, so we really need sort of an implementation strategy that is equally comprehensive. And so we're approaching this from a three-track approach to make it more digestible, really. And so the first track of this is to convert the current steam system to a hot water system. So Nina, if you can get into the next slide. We can see the three tracks here. So steam to hot water conversion allows us a lot of flexibility to be able to incorporate renewables into that mix. And so a variety of renewables. I'm going to jump to track 3 real quick. And so part of this exploration was our carbon neutrality source that we want for the major heartbeat of the district system. And the team has settled on geothermal as that major source for the campus. But the low temperature hot water system will allow us future flexibility to incorporate other renewables into the mix as they become available in the markets or within our community. So Mike will get into a lot of the details around some of the specifics on the 3-track approach. And the final one is track 2, the finance, the business structure by how this all happens. So with that, I'll turn it over to Michael to get into a lot of the specifics.
Thanks, Megan, and good afternoon, everybody. Thanks for joining us. So as Megan had mentioned, we really, when we were working through our planning and looking at options to get how we were going to get Oberlin College to carbon neutrality, we did really want to separate the different strategies that needed to be deployed to enable that to happen. And first and foremost was modernizing the campus, that track 1 approach of modernizing the campus, taking an antiquated steam system that was definitely the best technology 100 years ago, but is not the best technology today, and modernizing the campus infrastructure with what is the best technology today. And that's a low temperature hot water system. That low temperature hot water system allows us to more easily, more practically, and more cost effectively integrate multiple renewable energy sources for purposes of heating campus buildings. As well as then, as part of that, we went into the campus buildings and are intending, or will be going into campus buildings, I should say, and retrofitting much of the internals to be able to receive that low temperature hot water and properly and efficiently and cost effectively heat the various spaces. At the same time, as Megan had mentioned, beyond while we're in the buildings, there's many buildings that the college has determined ought to have cooling added to them. And I'm sure that'll make many folks on campus very happy. And we're essentially doubling the number of buildings that will be cooled. And on this map here, all the purple buildings you can see will be buildings that will have both heating and cooling to them when we are completed with the modernization, with the overall program. And so as part of this project in total, and part of this track one, is all of this distribution pipe, all of the antiquated steam pipe will be replaced with that low temperature hot water pipe underground. And then the chilled water pipe will be replaced so that it's modernized, very reliable, and be able to serve this expanded number of buildings that will be cooling. As we are in the buildings themselves, we'll also look at modernizing other utility infrastructure in the buildings, the fire protection systems, the electrical infrastructure, the IT, the campus fiber network. We are looking at this comprehensively and making sure that, as Megan said earlier, this is a once in a lifetime project. We want to do it right. We want to modernize as much of the campus as we can. Go to the next slide. So when we were looking at track two is really a very detailed analysis with some legal and financial partners to determine the most effective way to implement this program. And how can we do this while achieving the cost savings that the college wants to achieve over the long term? So we looked at a bunch of different scenarios of how this overall program could be financed and implemented. And with the guidance of the college leadership and of the senior advisors that the college brought in, we had determined that the best way to modernize the campus, address over $40 million of deferred maintenance when you look at both the distribution systems, the plant infrastructure in the buildings, and integrate all of these renewable energy sources, was to do it through a college debt funded program, where the college would control and finance the overall implementation of the sustainable infrastructure program, and driving that, allowing the college to realize the operational savings that come with it of over $1 million per year. Go to the next slide. So in 2016, when we originally started the carbon neutrality program planning and developed the master plan for the carbon neutrality program at Oberlin College, we looked at a wide variety of renewable energy sources. And on the left there, you see a bulleted list of all of those options that were practically viable in Oberlin and could be integrated in the overall program. And all of these solutions had varying level of applicability and viability, but each one of them are proven technologies that could be deployed if found to be the most compatible with the college infrastructure. On the right there, we identified the 4 that were the most viable: biogas, biomass, geothermal, and landfill gas, combined heat and power. We found those to be the most financially viable, practically implementable, and most compatible with the Oberlin campus and the overall goals of the Oberlin College. And we can talk a little greater detail about how we got to geothermal. But as Megan mentioned on the previous slide, that is where we've landed now. We went through a little bit of a process to get to geothermal. At one point, the landfill gas combined heat and power was the most practical solution and found to be the most advantageous. And that would be taking waste heat off an electric generation station at the Lorain County landfill, just a couple miles east of campus. But as we were working through detailed planning for the Sustainable Infrastructure Program, the generation facility at the landfill has changed their business model. And so that solution ended up falling away from being the most viable, and we moved us toward geothermal instead. Go to the next slide, please. So the goals that, going back to the goals that Megan had talked through, and now you see the results here and of what this Sustainable Infrastructure Program will bring to the campus, reducing over 5 million gallons of water consumption per year and 4 million gallons of sewer discharge, improving campus energy efficiency by over 30%, and some buildings even more than that. We will be essentially within 90%. All right, we'll have eliminated 90% of the scope 1 and 2 carbon emissions on campus by way of this modernization of the campus and integration of geothermal. And we're also creating a platform to be able to serve community buildings with this renewable energy solution as well. So that's a key component, that community integration, and the manner in which this is being developed and in which we are designing. We have the flexibility to be able to connect community buildings, in particular those adjacent to the Oberlin campus, whenever it makes the most sense for those buildings to connect to that carbon-free source. Next slide, please. So going back to the 2007 baseline of scope 1 and 2 carbon emissions, certainly a major chunk of those eliminated through the move from coal to natural gas as a primary energy source at the central plant. And then some other energy efficiency improvements that had been made on campus over the past 5 to 10 years. And now when you look at 2020, the common situation that we see on any campus looking to decarbonize is that first 30% is always the easiest to get, and the last 20% is always the hardest. And so this is showing Oberlin College as really a leader amongst its peers around the country, as not giving up when you get to that last 20%. We're by integrating the geothermal, we're going to be able to almost entirely eliminate natural gas combustion at the central plant. There is some decentralized natural gas combustion in some individual buildings for cooking and for some various other needs. As we roll into implementation of the primary component of this work, we'll start working on how we can eliminate that natural gas combustion as well. But by the end of this next 4 years of construction, we will be very, very close, and we'll be targeting those last remaining sources of scope 1 and 2 emissions. Next slide. So a little bit about geothermal. Essentially, a geothermal solution, when you go deep enough in the ground, roughly 600 feet down, there's a constant temperature of around 55 degrees. And so we're leveraging that constant temperature of the earth to both heat and cool our buildings. In the summer, we'll take that 55-degree temperature, we'll send water down tubes into the earth. It'll come back up at 55 degrees, and we'll use heat recovery chillers to take that 55 and bring it down to 42 degrees. And once we've done that, then it gets delivered out to the buildings to keep them nice and cool during the summer. In the winter, it's the exact opposite. We get that 55-degree water out of the core of the earth, and we use those heat recovery chillers to actually boost that 55 degrees up to 130 degrees. And then that allows us to heat the buildings, as well as provide domestic hot water for showers and kitchens and sinks and so forth. In certain parts of the year, and really throughout the entire year, the other benefit of this heat recovery chiller is you're actually doing two things at once. You're heating and cooling at the same time. So it's a very efficient means of being able to send hot water and chilled water to the buildings simultaneously. Because there are buildings, if you think about in October, some buildings may be a little cold and they need heat, and other buildings might be a little hot because they get a lot of sunlight and they would prefer cooling. And so by way of this program that we are implementing, we're going to be able to share that energy between the buildings, which just improves our overall efficiency, reduces overall costs for the campus, and is a more sustainable long-term solution. Next slide, please. So from a construction standpoint, the college had, we worked with the college to identify an area on campus where we would be able to deploy and install these geothermal wells. The green line it will interconnect between the central plant on campus right next to MUD and the north practice fields. The north practice fields are where we will be installing the geothermal wells. We won't take the whole practice field down at the same time. We'll drill in portions so that the student body can still utilize those fields while we're constructing. And when we're done drilling the wells, we will be restoring the surface back to as good or better condition than it has today. And other than some placards that'll be on the edge of the practice field, you won't even know that there's a well field underneath. So that construction on the well field is planned to start in 2023. And we'll have detailed design and planning over the next couple of years to prepare for that. The Oberlin College Board just recently approved geothermal as our solution. So from a construction sequencing, as I said, roughly a 4-year construction window. As Megan showed you with the pictures earlier, the south definitely is an area that's in significant need of rehabilitation and modernization. So we targeted that as our first area for construction starting this May. And then we'll be working ourselves clockwise around the campus, moving to the west, up to the north, and then to the east over subsequent years. So essentially the south in 21, the west in 22, north up in 23, and east in 24, with some minor overlap between, but generally speaking, that's how our construction sequencing will go. But really, South Phase 1, that's those are our first buildings. That's where we're having some major challenges now, and that's where we need to start. So that in this summer, that will involve South Hall, Harvey Cotta Price, Robertson, Conservatory Central, Warner, Baldwin, as the initial buildings, and then we'll be working our way to 2 other buildings after that.
So it's quite a comprehensive program, and we want it to be meaningful and intentional for campus. And so we've got a pretty robust and dynamic communications and outreach strategy as part of this program that covers kind of 3 major areas. One is project communications. Another area is the academic enrichment component of all of this. And then the third piece is community engagement and outreach for all of this work. And sort of, a key component of all 3 of these pieces is the educational backbone of our program goals and this program in general. And so I don't think there's anyone better than our students to talk about this component of it. So I'll welcome Stephen and Wenling to give a little perspective over the student input and take over this program work.
And thank you, Megan, and Michael and Nina for the presentation thus far. And so Wenling and I essentially have been part of this project for kind of since our freshman year. And I mean, the project hasn't really existed physically yet. So I think that is itself a tremendous opportunity. So if we think about like what the next 4 years are going to look like, that there can be a freshman coming in and seeing this project get underway and then ultimately see the benefits of it their senior year. So I think in a sense, this project is exciting because it is, it's a physical manifestation of who Oberlin is, who Oberlin says it is, and what students want. And I think it's a really concrete investment in the mission of Oberlin and its quest for carbon neutrality. So I think it is this tremendous opportunity, and sharing that opportunity with as many students is really paramount in understanding that learning doesn't need to happen inside of the classroom, and it can happen outside, and it can be integrated. And this project is going to impact every student in some way. And so, yeah, it's very exciting to be a part of. And I think if we think about the next 4 years and all that can come in the next 4 years, both in terms of organizations, in terms of embedment into embedding this program into classes that already exist. I mean, we can see really concrete examples, both, I mean, environmental studies, in geology, in economics classes. Like this project, because it is so multidisciplinary and it touches all students, that the programming can be really dynamic and just encapsulate everything that the project is and what it stands for.
In more detail, I think our involvement with the Sustainable Infrastructure Program is mainly threefold. Me and Stephen joined the Green Edge Fund since our first year, and the Green Edge Fund allocated $133,000 in 2018 towards the very initial phase of the Sustainable Infrastructure Program. That fund is dedicated for the initial research of the steam to hot water transition, and also for more research about the actual renewable source to be used. And also the Edge Fund allocated $202,000 last semester to expand the educational value of the whole Sustainable Infrastructure Program, so that we can use this particular example as a case study for a more integrated and hands-on learning of carbon neutrality. And we also got a chance to join the Carbon Neutrality Student Advisory Group. It is a very inclusive group, and every student can join it if you are interested in the topic. And I think from my second year and third year, it's like I'm learning all those knowledges related to energy, like district energy, geothermal energy in class. And I also got a chance to listen how our college is doing it in practice through the carbon neutrality student advisory group updates every semester. And also we are also the student representative on the Board of Trustees Sustainable Infrastructure Subcommittee. I think that is really a manifestation of how Oberlin College is empowering its students. I feel very privileged to be on the board and to listen to how the Board of Trustees, how the board members are viewing this project, how they are leading the college towards its carbon neutrality by 2025. So I think all those involvement is really a very meaningful part of my Oberlin career, and I really feel very lucky to be part of it. And Oberlin College creates such opportunity, not only for me and Stephen, but also for every Oberlin College student who are interested in the topic.
You know, I'll add on to a little bit of what Wenling said. And I think the curriculum integration is really kind of one of the parts that matters, because it's like thousands of students on campus that are going to be interacting with this project in some way or another. And compared to any other infrastructure project or any other capital investment, if we think of like a new building being put up, everyone sees that. However, really like surgical construction around campus is far less invasive, but the impact of the actual project aligns much more closely with what students want and the values that students have. So it really is trying to bring and elevate the stories that exist under the ground and what the technical inner workings of the campus infrastructure are. How can we elevate and bring that above the ground? And how can we build that into classes? How can we make curriculum integration really cohesive? And how can student organizations across campus leverage that storytelling and show more about some of the physical systems that are new to campus?
Thank you so much, everyone. Great presentations all around. I have to admit, I get the most kind of goosebumps, I guess, about thinking of the academic enrichment and student experience, and just so exciting to hear how this work becomes more than just a physical manifestation of energy and utility, but also what is the human dimension and impact of this work, right? We work on addressing climate change because of its impact in our world and our communities and to people. And so really driving all of that work back home and into the mission and purpose and experience at Oberlin is just, it gets to me every time they talk about it. So I just want to thank them particularly for that. I'd ask all our speakers to turn their cameras on and come off mute for our Q&A portion of the discussion. As we shift gears into that, I just want to make sure that I am putting up the contact information. So you've met Megan here today and Bridget, who also works in OES, who has worked on the student side of a lot of this work as well in community outreach. And both of them are happy to be a touch point for you if you have questions outside of this meeting. And again, directing you to carbonneutraloc.com for questions. So we have some time left here, so definitely don't want people to think we can't take more questions as we shift into that portion of the program. But also, you may come up with a question tomorrow, and I want you to make sure you know you can reach us, and not just on the technical side of things, but also on everything that was introduced around academic enrichment and communications. We really are just open to ideas and suggestions and opportunities for people to get into that discussion. So I want to make sure that you feel an open invitation to that. But we have had 2 questions sitting in the Q&A, and so I want to make sure that we shift into that portion of things. So the first question, I'm going to direct over to Michael with steam to hot water conversion. Talk about a little bit about how that hot water supply also works in showers, laundry, domestic hot water. Could you just get into a little bit more of what services this will include?
Yeah, so that the hot water will heat all of the domestic hot water inside in the residential buildings and the academic buildings and administrative. So it will provide the heating for showers and laundry and your sink and everything else. What we do is we actually have a separate. It's a technical requirement for that hot water is we have what are called heat exchangers, so that your domestic water, the water that you would use in a shower or in a sink, doesn't touch the district energy water. So there's stainless steel plates that keep those water streams separate, but transfer the heat over to them. So it brings their temperature up. So that definitely will be used to provide all of the hot water on campus beyond just heating of the spaces.
Thank you, Michael. So this one maybe is a good one for Megan to start with, and Michael can jump in as needed. But so what is the project lifetime of this? What's the outlook of the infrastructure? And how does the natural gas plant and conversion and upgrades play into this phasing and capital infrastructure improvement?
I love this question. And I think the latter part of this question, was the natural gas plant upgrade paid off, is sort of speaking to some of the specifics of the past history of the central plant and the upgrade. So just to get into a little bit of history with our campus district energy system and past investments, about when the campus was transitioning from coal to natural gas, and that was around 2014 timeframe. I think, yeah, it was March of 2014 was the last coal drop on campus, which many of us celebrated. But also it was a really pivotal point in terms of our carbon emissions. And so that upgrade to the central plant, the switch from the coal boilers to an investment in natural gas boilers, was always paid attention in this program work. That was always viewed as an interim step to get to carbon neutrality. And when the plant was being converted from natural gas, or from coal to natural gas, it was questioned by some folks on campus is that really interim, or are we just making this investment and that's going to be it? But it truly, this work proves that it truly was an interim step to get to carbon neutrality, and really speaks to the meaningful change and meaningful impact that this program work gets at. And what I mean by that is, it is not okay by our board or our students or our staff or any of us really to just buy our way out of this and offset by recs. Some of our colleagues in higher ed, that is a viable solution, but for our campus, we need to make meaningful change. So when we're designing this program work, though, we don't want to abandon that investment that happened. And so to get at the heart of the answer to this question is that the solution before us uses that investment as a backup option. So whenever you're planning energy systems, you have to, in order for it to be a reliable, resilient system, you really need to plan for some type of backup option. And we've got that because we invested in the plant back in 2014. And so we are not abandoning that investment, but it'll move to a backup as opposed to our base load under this scenario. And then in terms of the life frame of this program work, we're really like, system upgrades like this are about, 50 years or more. So that's generally the lifespan, but if you maintain it well and you operate it well, it will last much longer. Like our current system, it was really designed for about 50 years or so, but we've maintained it really well. And so now we're getting, 100 years out of some of these pieces, which is fantastic, but, everything has a shelf life, including, steel pipes and some other things. And so we're there. Michael, I don't know if you've got anything more to add.
Yeah, I just a few things. I think your comment, Megan, is very important for folks to understand, is that the integration of the geothermal with the central plant will enhance the reliability of the heating system on campus and cooling system on campus greater than it is today. So this program will actually add reliability and redundancy to the campus heating and cooling system. So that it's not as if that central heating plant, that gas plant will not be important going forward. It adds to that reliability so that on the coldest days of the year, the hottest days of the year, that we know we can still deliver heating and cooling regardless of, even if we have some type of disruption with the geothermal well field. The second thing is that central plant is extremely important these next 3.5 years to us, as we will be simultaneously sending steam and hot water out to the campus, and that central plant will be the primary basis for us doing that. So we are going to be, this summer, we're installing some equipment in the central plant that will allow us to take some of the steam that the gas-fired boilers are generating and convert that steam to hot water, so that as we finish the South Campus construction modernization, we'll be delivering hot water to the South Campus buildings that we've modernized while still sending steam to other buildings around the campus. So that central plant is pivotal for us to be able to deploy that strategy.
Thank you, Michael and Megan. We have a question that I think is a good accompaniment or follow-up to this conversation about the infrastructure and the role of gas with this. So during Michael's presentation, and I'm going to go back to this slide, that after 2023, there will be ongoing reductions in CO2 emissions, even while continuing to have some reliance on natural gas. Would this be accomplished primarily through efficiency measures? Are there plans currently to replace the natural gas generation completely? So I'm going to go back to our.
And as you're going back there, Nina, I can start, and then Megan can add in. So it's a little bit of a mix of all. There are some natural gas-fired boilers that are in certain buildings around the campus that were installed at some point over the years for various reasons. Could be that the building is too far away from the steam system to have connected it. Could be that there was something unique happening in that building that needed a different level of heating than the steam system was able to provide. And there are a few buildings where we will be putting in some temporary gas boilers just to support the construction sequencing that's happening on campus over the next several years. There's some kitchens that have some gas combustion with some localized equipment. So there's all throughout the campus, there's just some little spot areas where there's some natural gas combustion. Our goal is to eliminate all of that, and some of which will happen as some buildings get renovated through a more major renovation, not just a modernization of the utility infrastructure in the individual buildings. Some of it will happen toward the end of the program. Some of these temporary boilers will get installed now, but as the hot water system gets connected to them in, say, year 3 or year 4 of implementation, then those hot water boilers can be decommissioned. And some of them we still have to come up with a plan for them. And as you can imagine, it's been a real sprint for us to get from last summer to now to be prepared to break ground in May. As we get past this initial swarm of work activity, we will have time to take a bit of a pause and relook at wherever any of that natural gas combustion still will be happening toward the tail end of the hot water conversion, and then start coming up with individual strategies building by building to eliminate that gas combustion. So our goal is by 2025, and that's the commitment the college has made, is to have eliminated that. And now we'll start, we've gotten the bulk of it, that 90% with this sustainable infrastructure program. But then that last 10%, we need to start coming up with individual case-by-case strategies to eliminate that.
So just to sort of emphasize this component of it, and just to, our work is never done, especially in the sustainability and specifically the carbon neutrality space, right? We always have more to do, and that is definitely true here. So the focus of a lot of this work, and the biggest impact it needed to be the focus, was on our heating infrastructure. But there are some buildings that are not connected onto our district system. And so I had mentioned that, we are able to impact that carbon profile pretty effectively and efficiently by addressing our district energy system needs. But there are some one-off buildings that still need to be addressed. And that's where that sort of 11% at 2025 comes into play. And so now that we can get this underway, we'll focus on some of those areas. So this work is really specific to scope 1 and 2 greenhouse gas inventory emissions. But there's a whole nother scope as part of our carbon profile, scope 3, that we will also need to focus on, and is not really captured here in this work. So we'll focus on that in the next 4 years too. Specifically, travel and waste mitigation are big components of our scope 3 emissions. So I just wanted to sort of give everyone that heads up on the horizon. This, just because we're sort of presenting on the sustainable infrastructure program, it is not our total carbon neutrality program work. There is still more work to do. And like Wenling and Stephen said, lots and lots of engagement, and we need your help on all of those fronts. This particular program work and as well as some of the other pieces that we'll get into in the next 4 years.
Thank you. So we have another question that's come in. The question is, the Science Center is one of the least efficient buildings on campus, as the person posing the question has been told. So please clarify regarding that. What system is the Science Center on now, and how will it be converted?
Go ahead, Megan.
It is one of our largest energy users on campus. So we kind of have a target on some of our large energy users in terms of our inventory. Electricity wise, it is a huge user also. And so just because we are fortunate enough to have a municipal electric grid that is green doesn't mean that we don't also focus on some of the efficiencies with electricity. So I just wanted to sort of clarify, but across the board, whether you're talking about heating or power, the Science Center is a big draw. That is not uncharacteristic of college campus. Oftentimes, just by the nature of what happens in a science center, the loads are pretty large for that building. So it's not unreasonable that the Science Center is one of our largest energy users from all fronts. It is connected onto the district energy system. And so both from a heating and a cooling perspective, and that will continue through this program work.
Yep, and it's on the steam system now, and it will be connected to the hot water system when the hot water system is brought up to the north side of campus. So the details of exactly how it all will be configured, I'm sorry, I can't answer that quickly, but we will go into the building and retrofit all of the systems, the air handling units and the piping and so forth, so that it can receive hot water. And we certainly will be working very closely with the building stakeholders to do so in a manner that's as least disruptive to programming in the building as possible.
Thank you. A question on one of my favorite topics, solar thermal. It sounds like various sources would be able to feed into the hot water system. Is solar thermal going to be looked at to utilize? This says building rooftops, but just knowing that ground standing is also an option. Could you speak a little bit more to any other integration of, if not solar thermal, other renewable thermal that has been discussed?
Yeah, so you're right that the hot water system does enable integrating energy sources from a number of different sources, not just the geothermal. Particularly when you look at waste heat, as we work to integrate with the community, there could be circumstances where there is a waste heat source that could place the heat into our hot water system, so that we could actually leverage that as part of our utility system. Solar thermal definitely is one means of being able to warm up that hot water. And definitely as we look at those site-by-site solutions that I talked about just a little bit ago, where we need to get to that last 10%, solar thermal could definitely be a part of that. You're right that we did look at solar PV as one of the base programmatic solutions integrated with thermal storage. So electric resistance heat to generate hot water, because your hot water consumption, as you can imagine, over a 24-hour day, it peaks. So right away in the morning when everybody wakes up, takes showers, has breakfast, you have a peak of that hot water use. And then again, when everybody comes home for dinner, you have another peak. And then there's a pretty high level of usage during the day when folks are in buildings. So the solar PV coupled with the thermal storage with the storage tank allowed us to be able to manage that peak component of the hot water usage. The solar thermal here could be a solution for us to eliminate those remaining 10% of gas consumption on a building by building basis. So it definitely is going to be what we're looking at, or a component of what we look at.
Michael, just one follow-up to this. Could you give some examples of waste heat?
So waste heat off of data centers is one option or opportunity. You know, even within the science center, there's heat being exhausted out of some of the stacks that could be captured and reused. When you look at industrial process facilities where they need a higher temperature for their individual process, not that there's a lot of that in town, but there's a little bit of it. And if we're close to some of those waste heat sources, we could pull them in. So if you think about an industrial process where they have a big boiler for purposes of heating up a fluid, a recycling facility or something like that, those types of facilities all use a lot of high intensity heat to be able to work through their process. And then we could take the waste heat off of that for purposes of heating our low temperature hot water. And the lower we keep our temperature, and that's why that 130-degree temperature is so important. The lower you have that, the more heat sources are out there that you could leverage.
Thanks, Michael. So with no other questions in the Q&A, although I appreciate the comments.
I think there is one more, Nina.
They're
It's a comment.
Comments.
Yeah, sorry.
Thanks. That's all right. You get to do all the cool technical stuff. I'll keep the Q&A on track. So I want to toss one over to our fantastic students because I was so glad they could join us today. And I know we probably have some other students in our audience. So I'm just wondering if either of you want to offer anything else about the program, especially because as Stephen said at the beginning, he's been through a 4-year cycle of this. Anything in particular about your experiences alongside the program that you are really carrying with you or have been really impactful? That would be really great to hear.
Yeah, that's a good question about like what the biggest takeaways are. I think what comes to mind first is how interdisciplinary not only this project but all of sustainability on campus is. And I think even if we look at the organizations that affiliate themselves with energy usage, efficiency, broad sustainability, like how to create sustainable communities. This is all very in tune with how Oberlin students view the world. And I think if we look at the specific microcosm of the campus as like a little city, if you will, how can you design a community that is socially and environmentally sustainable? And I think the first thing in that is making sure that there is this constant communication and this constant connection, and so that student voices are heard, and in turn, those who are listening to student voices take those and internalize those. So this I think directly relates with one of the comments that we had, in that, like, if biogas or biomass was the heat source that was chosen, I think there would be some pushback from students. But given that students were involved in this whole process, I think that is something that could be prepared for in the future. Like, that's something that I assume Megan saw throughout this entire process, is that, like, students on campus have preferences in the heat sources and are really in tune to the inner workings of efficiency and energy sources. So I think that throughout this process is that there are some, from a student perspective, there are some fuel sources that would be more acceptable than others. And I imagine that that's something that is only possible because it is leadership that listens to students, specifically related to sustainability, and students that make sure that their voice is heard. So I would just say that the squeaky wheel gets the grease, and it's about involvement, and it's about listening and making sure that your voice is heard.
Stephen, Wenling, would you add something there?
I think definitely interdisciplinary nature of sustainability efforts is really important. And I think for me individually, the finance aspects really stands out to me. So we have a lot of different efforts towards resilience and sustainability. We have very cool project ideas, but after all, we need to do something that is financially viable. We need to have bankable and financeable projects. I think that falls under the scope of sustainable finance. Other perspectives, a company also need to pay for its carbon neutrality goal. And on a larger scale, a country also need to pay for its carbon neutrality goal. I think I am, like, both in my career and academically, I'm very interested in sustainable finance. And this actually translates to one of my economics research on green bond, like those research on innovative financial instrument. So I'll say the finance aspects is what affects me the most.
That's so great to hear, especially on that interdisciplinary thing, because it reminds all of us that whichever career path or life path we're on, we all can be impacting a better environment and a more sustainable world around us. So I really appreciate those comments. We've got time for one last item here, which is still on sort of the same track. And this question about, given some of the educational involvement with the AJLC, if maybe Megan could speak to a few other, or Wenling and Stephen, about some of the student involvement in the project to date, or a couple things we're thinking about going forward as far as, internships and curriculum and student learning opportunities. Megan, do you want to start?
Yeah, sure. I will start, in part because this, as a staff person here, our students help keep me real and help drive my work and make it incredibly meaningful. So this is a big intentional piece of our Office of Environmental Sustainability, and specifically with this Sustainable Infrastructure Program work. And it always has been designed to do so ever since, we really started this strong piece of the work back in 2014. So, there's been, throughout the last 7 years or so, there's been components of the program work that have pulled in internships that are specific to this work. There's also been some integration with some of the GIS platforms that we utilize in an energy program like this. And so but all along the way, this program work has been informed by, Wenling mentioned it, the carbon neutrality Municipality Student Advisory Group. So all of those student components, internships, advisory groups, board representation to the Sustainable Infrastructure Subcommittee of the board, it's all very intentional and inclusive of having that student input in all around education. So this has been a complete added bonus for all of our industry partners that have worked on this also. So we've encouraged everyone to have some internships as part of this. And so one effect of that I did not expect that has been really fun to see is that, you know, I mean, this is very much an administrative kind of capital planning project that we're including student input and student engagement and student learning in. So, you know, that in of itself is really great for our capital planning project teams in general in our approach here, but also for our partners, the engineering firms that we get a chance to work with. They get a chance to work with our students, and our students are amazing and stellar. And so they have, you know, I think I don't want to, just speaking very frankly, as soon as, you know, I mentioned something like this, a lot of engineering firms are like, oh, students are going to slow us down in our project timeline. And that is not the case at all. It's total emphasis. So that one map that we had where we had the different timeline and different phases, that was the direct work of one of our amazing GIS internships as part of this program work. So Rebecca had a chance to, you know, input all of these GIS layers that now our institution has ownership of these and can use in some of our curriculum components. So that is probably the most recent highlight of some of that student education learning input in just this planning and design phase of the work.
Right. I'm realizing we are over on time. I guess I would give the last word to either Stephen or Wenling as far as groups or suggestions on where you would point students who are still in the Zoom with us on where you might suggest they get involved, not just on the SIP program, but just thinking about carbon neutrality and environmental stewardship work in general. Or maybe Wenling is in a finance club that really likes to talk about climate change. Any last suggestions there?
I'll say anywhere. I mean, I think anywhere students are involved in sustainability one way or another. So ask around, ask Wenling or I. We've been immersed in it for the past 4 years and have a pretty solid understanding of the landscape of what exists out there. But I would say there's no wrong way to start. There's no wrong way to take the next step.
And also, like in a concrete way, look for Carbon Neutrality Student Advisory Group information on Campus Digest and join this group.
Fabulous. Thank you, everybody, for being with us today. I really appreciate just all the earnest participation and how authentic everybody is in trying to share information. And for those who are still on the Zoom with us, if you can think of any other ways you'd like to help us enhance our outreach and connection and work in this program, please know our doors and our email are open. Please do reach out to us, and thank you, everyone, and have a really wonderful afternoon.